On number 6, we start working with the same graph for quite a while. So I clear out whatever I have in there, and I type it in. It's 2 times 5 raised to the x power. And then we subtract 3 at the very end. Guys, please, tomorrow, double check this specific number 6 that you type in. Double check it before you get moving on. Because if you type it in wrong, you're going to get a lot of wrong answers in a row. Okay, because we use it for the next several problems. So I double check it. It is typed in correctly. And we're going to now find the x-intercept. So let's take a look at it. Zoom 6. And if I don't zoom 6, if I'm just lazy and slapping the graph button, notice that it's just not going to look good. Okay? Like, that doesn't help us with anything. So always start off with zoom 6. Zoom 6, nice pretty graph. Now I look up here and I say, okay, x-intercept is between 0 and 1. And for me, that'd be enough for me to at least take a look down and scan my answers. If there's only one decimal answer, like 0.25 or 0.5, I'd go with that answer as an estimation. But let's be perfect with our work, okay? Let's do second, calculate, and what we're looking for is a 0, okay? So we go to the left a little ways because it says left bound. What it means is left bound of right there where I have the mouse pointer. Okay, that's what it means, left bound of that, the x-intercept. So I'm to the left of it now, so I press enter. I scroll till I'm to the right of it. Oop, went a little too far, come back, there we go. I am now to the right of my x-intercept, so I press enter again, and then we don't guess, we press enter. And we get exactly what I kind of guesstimated earlier, 0.25, 0. Next, number 7 says identify the y-intercept. Well, there's a couple ways to do that. Some people like to use that value function. I always just tell people to look at the table. Because for all you know, your x-intercept may turn up there every once in a while too. But in this case, it did not. But we can see the y-intercept. Y-intercept is always 0 and then a number. 0, -1. You can also do that by just looking at the graph on a lot of these exponentials. Okay? 0, -1. Next, the horizontal asymptote. There's 2 ways to do that. 1, by looking at the graph and knowing how horizontal lines work. 2, by using our trick. Our trick is that this is the new life purpose of the number at the very end. This tells us the horizontal line that our graph is flattening off at. So according to the equation, it's saying our graph is flattening off at the horizontal line, y equals -3. And you can kind of see that this is 1, 2, 3, and that's where it's flattening off. So that is your final answer. Y equals -3. Again, it has to be y equals. Has to. If it's not there, it's wrong. Okay? Next, identify the domain. Domain means all possible x values. Well, this is going to go left forever, and it's going to the right forever, which means it's going to have all of the values from -infinity to +infinity. That is all the possible x values. All right. Number 10 is trickier. 10 is identify the range, which means all the possible y values. Now, I guarantee you there's going to be an answer on there that says this, trying to get you. Take a look at the graph. This is certainly going to go up forever, but it's not going down forever in the traditional sense because it's getting capped by that asymptote. So the range and the asymptote have a lot to do with each other. In fact, they look very similar, except for now, instead of an equal sign here, we're going to take that equal sign, we're going to close one of the ends up to make it a greater sign or a less than sign. We do that according to how the graph looks. Here's my flat spot, here's my asymptote. And I've been asking all along, I said, okay, well, where's the rest of the graph? Is it above or below that asymptote? And this graph is all above the asymptote, meaning it encompasses all y values greater than -3. -3 is the lowest it's ever going to go. And in fact, it can't even quite get there. Okay? But that range is everything above that. Next, number 11, interval of increase or decrease. Okay? So we have to first determine which one's it doing. Well, from left to right, we see that it's increasing. So that would be the first thing to look for, is whichever answers say increasing. Next, you're going to be looking for the correct interval. This one is increasing all the time. And the way we mathematically say all the time is with negative infinity to positive infinity. That's how we say the all the time sort of phrase. Number 12 is our final piece of this problem. It's the last thing we need to be able to put on here, okay? And it is end behavior. I warned you earlier today, end behavior is really hard to read for a multiple choice question because there's just so many letters and symbols riding around. But the ones that are always the same are these. As x approaches negative infinity, y does something. As x approaches positive infinity, y does something. What changes from problem to problem are the values that y is approaching, okay? So we look at our graph. This top part means as x approaches negative infinity, that's just a fancy way of saying left side. So if we start at the middle of our graph and we start walking to the left, we see what's happening. We see, oh, we're flattening out. This has become a nice, pleasant little stroll, okay? We're flattening out because that is the asymptote. And we already had to list what the asymptote was once. It was -3. So can't find the asymptote, going to have a lot of tough time on end behavior. Next, we figure out what my other end, my right end, is doing. Well, if I start here in the middle of my graph, I start walking towards the right, I'm climbing a rock face, okay? I'm scaling a building here. That's going up. And so it's going up as high as it possibly can because that graph goes on forever, meaning it's going up to positive infinity. It's end behavior. Because it was new, end behavior also got a bonus problem on here in the form of number 13. Again, the setup will be the same. And this is all done for you, so you just have to pick the right answers for what x is approaching. Again, left comes before right, because that's the way we read. So left side of the graph is doing what? Right side of the graph is doing what? So we have to graph it to find out. Okay? This was a -5 times a fraction of 1/2. Close it off, raise it up to the x power, and then add 3. Hit graph and take a look. Well, eventually take a look. Okay? So, we start in the middle of our graph and we start walking to the left because left comes first. And we see that we're going down, 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 down. There is no stopping that train. That thing is going to go down forever and ever and ever. So, as our x goes to the left, our y goes to negative infinity. Then we check the right side. As we go walking, it's going up, 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 up. But then it starts to level. And it's leveling off at an asymptote. But we haven't had to talk about the asymptote for this problem yet, so we have to actually go find it. It's right here. So my left end went to negative infinity. My right end went to the asymptote of 3. A reminder for tomorrow, one of the answers on 12 and 13 will always be an asymptote. And the other half of the answer is whichever infinity the other end's going to, positive or negative. So it's always going to have the asymptote in the answer, and then you got to decide which infinity is it on which side.